everyone, and welcome. My name is Sarah.
And I'm Libby, and today we have a topic that's going to go beyond the basic levels. Get it? Oh, yeah, I forgot to tell you the topic. Today we're going to be talking about the acidification of oceans. Woo!
Yeah, the ocean is taking a pretty big hit from oceanic warming, and now acidification.
Oceanic acidification is caused by increased carbon dioxide levels in the atmosphere. But where does all this carbon dioxide come from?
Oh, I know. It comes from the burning of fossil fuels.
Butane is one type of fossil fuel. This is the equation for the combustion reaction of butane.
But there are many other fossil fuels that can contribute to the rise in CO2 levels, like methane or propane.
The reactants in this equation are oxygen and the carbon compound like butane, methane, and propane, while the products of this equation are carbon dioxide and water and energy in the form of heat. But why does this matter, you may ask? Let's look at how the oceans help us.
Besides being beautiful, the ocean has been a huge help in slowing climate change by absorbing large amounts of carbon dioxide in the air, a third to be more exact. Once in the ocean, the carbon dioxide plays a vital role for plant life, who use the carbon dioxide for their photosynthesis.
The increased amount of carbon dioxide in the ocean creates carbonic acid, which is just when carbon dioxide bonds to water molecules. When the carbon acid breaks down, it loses positively charged hydrogen ions, or hydrons, and creates mostly bicarbonate. Sometimes, carbonate is created which can later combine with calcium to become calcium carbonate, the building block for shells, coral, and many sea animals. Anyway, in a neutral solution, the amount of positive hydrogen ions is the same as the amount of regularly made hydroxyl atoms, which are just OH negative. With the extra positive hydrogen ions, the ocean becomes more and more acidic. Calcium carbonate is very reactive with acids, and therefore an increase in acidity, even slight changes, can dissolve the calcium carbonate of the coral reefs and the shells of sea life. As a result, coral reefs are dying, fish have softer shells, and all sea life is suffering.
I don't think they believe us quite yet.
They might not, but they will after this.
This is some tap water in a flask. There are a few drops of universal indicator in it. This registers the pH of the water. Now, as air is blown into the water via the straw, the carbon dioxide from the air will mix with the water, making it more acidic. The change in the color of the water was the universal indicator reacting with the CO2 in the air.
I've got a lot to do too. All you're going to need is an egg and some vinegar. This is just some common kitchen vinegar. And so vinegar is an acid, and the shell of an egg is calcium carbonate. So if we were to completely, cover this egg with vinegar, in about 4 to 5 days, it should look pretty much like this. What happens is the shell is pretty much dissolved by the acid and just left with the skin of the egg and, the yolk and whatever's inside. So, do you think they believe us now?
Yeah, I do. Both labs prove what acid can do to water and what it can do to the animals living in the ocean.
So there it is. Carbon dioxide is really vital for the atmosphere and the ocean, but too much of anything is a bad thing. Let's keep our environment clean. Thanks for listening. I'm Libby. This is Sarah. See you later.
Bye.
Do your part to help the environment and the beautiful sea life.